All right, review guide for the spring exam. I'm going to do both accelerated and non-accelerated together. 1 through 30 are the same questions. And then after that, the questions will be different. So I'll let you know when that switches up. Okay. Look at number 1. Remember, we condense logs to a single logarithm. We multiply if it's addition. So that'll be 5 times 2 gives us 10. Number 2, that'll be 40 divided by 2, which gives us 20. So we have log base 2 of 20. Number 3, you can just put that in your calculator, or you can put it in exponential form. 3 to the x equals 27, which would be 3 to the x equals 27 would be 3 cubed, which gives you x equals 3 there. 4, natural log is the same thing as log base e of e to the x. When the base and what it's multiplied is the same, the exponent's the answer. Number 5, we just have to set that up as x minus 6 equals 4x. Subtract x, negative 6 equals 3x. Divide by 3, x equals negative 2 there. All right, number 6, inverse there. To get that inverse, we switch the x and the y. 3 to the y, drop, hook, hook. We get y equals log base 3 of x. Okay. 7, I just did this. You need to do this in the calculator. Drop to the base, hook, hook, log base 5 times 3 in the calc. All right, number 8, remember we're solving for b there. So we'd set that up as 243 equals 27 times b squared. Divide by 27, 9 equals b squared, square root each side. b equals 3. So when we plug that in, get our answer there. Number 9, solve for x, bring up the x, hook, hook, put it in exponential form. X cubed equals 27. Cube root each side. We get x equals 3 there. Number 10, bring up the 25. 5 to the 2 minus x equals 25 to the negative first, but I'm going to go ahead and make that 5 to the negative second. We bring it up, makes that exponent negative, and 5 squared is 25 there. So then we can drop the base. 2 minus x equals negative 2. Subtract 2. Negative x equals negative 4. Divide by negative 1, and we get that x equals 4. 11, square both sides. 4x plus 2 equals 2x minus 2. Subtract 2x. We get 2x equals, subtract 2, negative 4, divide by 2. We get x equals negative 2 there. Number 12. Cube root of x to the 9th is x cubed. Cube root of 27 is 3, so we get x cubed over 3. 13, we need to rationalize the denominator. Multiply by square root of 3, which gives us square root of 3x to the 5th over 3. And then 2 goes into that 5 twice, so we have x squared. Remainder of 1, so we have an x to the first power left in that radical over 3 there. 14, since we assume all variables are positive, we won't have even, odd rule. But the 4th root of 625 is 5. And then 4 goes into 4 one time, so that answer is 5z. 15, 8 to the 1/2 power can be written as the square root of 8. 16. You can just plug that in the calculator. But the fifth root of negative 243 is negative 3, and then negative 3 cubed gives you that negative 27. 17 does the same thing as 8, or 8 to the 1/3 is 2 times 2 squared, which that gives us 2 times 4, which gives us 8. 18, I just multiplied across there and simplified to get that 10x over 3. 19 square root of 5 squared, that equals 5, which is the only thing there that will be a rational number. Remember, a rational number is not a radical, all right, or a decimal that does not repeat, okay? So, got that answer there. Think of it as you're just looking, needs to be an integer. 20, that ranges from negative 5 up. So all y values greater than or equal to negative 5 there. All right, 21, we get that vertical asymptote from the denominator, the x plus 3. We set that equal to 0. Okay, I'm actually going to back this up. All right, so we got, sorry, this x plus 3 equal to 0 gives us x equals negative 3, so that's our vertical asymptote, so we know it can't be b or d. And that 5 gives us our horizontal asymptote. You can also plug it in your calculator. Look at that graph, you should be able to see the asymptotes there. 22, we want to multiply by the reciprocal. So we got x plus 4 over x squared plus 5x minus 14 factors to x plus 7 times x minus 2 times x minus 2 multiplied by the reciprocal, x minus 2 times x minus 2 over, need to factor, we get x plus 4 times x minus 2. From there we're going to cancel, 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 and all we're left with is 1 over x plus 7. 23, if you plug 2 in, it does not work. That's a no. 24, we need the same denominator. So x squared minus 9 is x plus 3 minus 3, so that'll be minus. I need to multiply the right side by x minus 3 to get the same denominator. Distribute that negative 2. 3x minus 5, and that'll be a negative 2x plus 6. Remember, we're distributing negative 2 there over x plus, and so then combined like terms, we get x plus 1 over that x plus 3x minus 3. 25. You can cross multiply. You can also, since the denominators are the same, just set that up as 6x plus 4x plus 6. I cross multiplied, kind of did too much work there, but at the end you will get x equals 3, which if you plug that back in, it does work. All right, when I factor that, I also got negative 3. Negative 3 would not work. Okay, so make sure you plug back in. (26) exponential growth. We're looking at b there. Can't be c. C is a parabola. D is linear. Has to be a or b. And then since b is 3 on answer b, that tells me it's growth. 27, I'm going to set up my geometric sequence formula. So first term's negative 1. My rate is negative 5 divided by negative 1, which is 5. Since 10th term, we do 10 minus 1, which will give me to the 9th power, which gives me that huge number, negative 1,953,125. 28, we need to square both sides. which that gives us x minus 3 equals 25. Add 3, we get 28 there. Okay. 29, you need to square both sides. That gives you x plus 2 equals, remember, x minus 2 squared, you got a FOIL, which gives you x plus 2 equals x squared minus 4x plus 4 after you FOIL the x minus 2's. All right, subtract x, subtract 2, we get x squared minus 5x plus 2. So you could do the Pythagorean theorem to get those solutions, but for this case, that would be a fine answer. Okay. All right, 30. Now 30 is on both exams, accelerated and non-accelerated. All right, need to bring up that e, hook, e to the 6 equals x. So we get 403.43 there. All right, now this point here, the rest of this is going to be accelerated, and then I'll tell you when I switch back over to just Algebra 2. It'll come back to question 31 when it comes back to Algebra 2. Okay, so 31, what are the coordinates? The angle 2 pi over 3 radians. So what I like to do is multiply it by 180 over pi, which in this case, that would give me 120 degrees. So looking at 120 degrees on the unit circle, okay, I'm thinking we got 90, 120, 135, 160. So since 120 is shorter than that 160, okay, and I know x is going to be negative because I'm in quadrant 2, okay, that means my ordered pair is going to be negative 1/2 comma square root of 3 over 2. The reason why, what helps me remember that is square root of 3 over 2 is longer than 1/2. So D would go with 160 degrees. Or 150, I'm sorry, 150 degrees. D would go with 150 degrees on the unit circle because that's longer. It's the way I think of it in my head, okay? 32, same terminal side there. Again, find the degrees in this case. That would be 150 degrees. So what the answer will look like on the exam would be negative 210 degrees. Same terminal side going clockwise there would give me negative 210 degrees. All right, what is the cosine of pi radians? Pi radians is 180 degrees. And remember, it goes cosine and sine, so that gives me negative 1 comma 0. So the cosine would be negative 1 there. 34. I got 5 pi over 4, which would be 225 degrees, which tells me that's in quadrant 3. 3 pi over 2, that's 270 degrees, which means that is at 0, negative 1. Remember, it goes cosine, sine, so that answer would be negative 1. $36. All right, I need to do cosine of 37 because I have adjacent and the hypotenuse equals x over, or 11 over x, I'm sorry. So I'm going to multiply by x. Give me x times the cosine of 37 equals 11. And then divide by the cosine of 37, which that gives me about 13.77. Obviously, that's not degrees. It's a typo there. All right, so 37, I'm finding the inverse. So first I got to find the determinant, which is 8 minus 6, which is 2. We do 1 over the determinant. We flip a and d. We multiply b and c by negative 1. distribute that 1/2. And we got our inverse as -1, 1, 3/2, and -2. The determinant, that'll be 6 minus 2, gives me 4. 39, that angle, looking at opposite over adjacent, so I'm going to do the inverse tangent of 11.9 over 10. Maybe 49.96. And 40, that's adjacent over hypotenuse, so I'm going to do the inverse cosine of 12 over 13, which gives me 22.62 degrees. All right, 41, I changed these all up. Okay, remember 41 was C minus B. All right, C minus B. 42, A times D, you cannot do, okay, because we have 2 by 3, and D is a 2 by 3. Since those dimensions don't match, they won't work. You can't the rows and the columns don't match up. All right, 43 we can multiply. I'm going to go ahead and multiply that here. So I'm going to erase these solutions and multiply A times C to work through those operations for y'all. So 535,150 times 0, -3, -5, 5, 1, 1. All right, so remember to multiply rows by columns. So I will have 5 times 0 is 0, plus 3 times -3 is -9, plus 5 times -5 is -25. And then I will have, hold on, let me move this. And then I'll have 5 times 5 is 25, plus 3 times 1 is 3, 5 times 1 is 5. And then I'll have 1 times 0 is 0, plus 5 times -3 is -15, plus 0 times -5 is 0. And then 1 times 5 is 5, plus 5 times 1 is 5, plus 0 there. So that answer, so we get our negative 34, 33, -15, and 10. All right, next section here. Get our solutions. Okay. And we're finding the difference of the diagonals on the determinants. All right, 45, you had to multiply first the rows and the columns to get 3, 9, 13, 1, -35, -2, and then add it to that matrix, right? Order of operations. 49 again, right? Difference of diagonals there. 50, finding the inverse. Okay. Find the determinant. We do 1 over the determinant. We flip A and D, and we multiply B and C by -1. Then we distribute that 1/12 to each term. (51), again, we're finding the inverse there. 52, we're graphing the exponential function. The x values I would use 0, -1, and 1. Having done the exam, I would just go ahead and use those. Remember, this 1 gives us our asymptote right there. Okay, so that moves it up and down. We just want to plug those x values in for x to get the y values to get our exponential function. That domain's all real numbers. It covers every x value. And the range is y is greater than 1, because that graph will cover every y value greater than 1. Last question. We set up our trig functions. Okay. So -4, we're left 4. 10, we're up 10. Pythagorean theorem to get the hypotenuse, which gave me square root of 116. Okay, since there's no calc on this section, okay, if you left it as square root of 116, that would be fine. May or may not be a rational number on the exam. I don't know. You may not have to worry about that. But I don't know. We'll see. But then from there, we'll do our 6 trig functions. Okay. All right. And remember, on what happened on the sine and cosine there was I had to rationalize the denominator, which I did in the purple and then the black right here. And that's how I got what I got. Okay. All right. Now, that's the end of accelerated. Back to Algebra 2. 31, that geometric sequence, we just have to set it up. 5 times 3 to the 5 minus 1 power, which that gives us 405. 32, we have to solve for A1 first. So A3 is -16 equals, trying to find the first term. Rate is -4. Since we're given the third term, we're going to do 3 minus 1 there. Gives us -16 equals A1. -4 squared is 16. Divide by 16, and that first term is -1. So to find the sixth term in that sequence, we'll have -1 times the rate, -4 to the 6 minus 1 power, which gives us 1,024. 33, bring up the 3, hook, 3 to the 4th, gives us 81. 34, bring up the 5, hook, 5 squared equals x, so x equals 25. There, bring it up, hook, bring it up, hook. 35, condensing division, or subtraction means division. So we get x divided by y. 36, addition means to multiply, so that'll be a squared times b. 37, that'll be log base 5 of x divided by 5 equals log base 5 of 5. Drop the logs. X divided by 5 equals 5. Multiply by 5. X equals 25. 38, again condensing, that'll be 25 times 5, which is 125. Since there's not logs on both sides, we got to put it in exponential form to solve here. Bring up the 5, hook, 5 to the x equals 125. All right, you could do log base 5 times 125 in your calculator, but that would give us x equals 3 there, because 125 is 5 cubed, so x equals 3 there. 39, we'll put that in logarithmic form. Drop the e, it'd be natural log of 4, which gives us 1.39. Okay. All right, drop the e, hook, natural log of 4 equals x, it's 1.39. 40, need to bring up the e, hook, e to the 4th equals x minus 3. All right, we had to take it from logarithmic form to exponential form. Then I want to add 3. So e to the 4th plus 3 is going to equal that x. E to the 4th plus 3 give us 57.6. All right. Next part here. 41, we got to get the same denominator. So in this case, that's going to be 6x squared y. So I need to multiply the right side by xy and the left side by 2. Gives me 2x plus xy over 6x squared y. Since all three terms have an x in it, we can simplify that and move an x. So it would be 2 plus y over 6xy. All right, 42. To graph that function, we're going to have our vertical asymptote at x equals 2. The domain is not all real numbers. X equals 2. Get that from the denominator, x minus 2 equals 0. There's no number to the right side, so our horizontal asymptotes at y equals 0. Make sure you draw both or you won't get it right. There is no x-intercept because we have our asymptote there. And you can plug this function into your calculator to look at that as well. Y-intercept, plug in 0 for x, and that gives us y equals negative 1/2. So we do have a y-intercept at negative 1/2. So I'm going to redraw that to get that y-intercept. Right, again, to get that y-intercept, just plug 0 in for x. Then that domain is going to be all y values greater than 2 and all y values less than 2. It can't be 2 because we have an asymptote there. Okay, and I wrote y, that should be an x. I don't know why I wrote y. Sorry. It'll be all x values greater than 2 and all x values less than 2 for that domain. Yeah. All right, 43. Need to factor. Take an x squared out of the numerator, x plus 3. Denominator is x plus 3, x minus 3. Can cancel the x plus 3's. We're left with x squared over x minus 3. 44, same thing. Need to factor. X minus 4 over x plus 4 times x plus 4 times the numerator there, that'll be x plus 4 times x plus 1. 4 times 1 is 4. 4 plus 1 is 5. And then difference of squares in the denominator, which will give us x plus 4 times x minus 4. Now we can cancel. Cancel. We're left with x plus 1 over x plus 4 times x plus 4, or we can write that as x plus 4 squared. (45) Graphing that square root function. Okay. Take the radicand. Oh, I changed it to square root x minus 2. Gotcha. Change those numbers. So take that radicand. And get x minus 2 equals 0. So let me go back. Take the radicand. X minus 2 is equal to 0. So we get x equals 2. So I plugged that 2 in, which gave me 0. So my first point's at 2, 0. Then, so the way square root functions work, they start there, they go to the right. So I can choose any x value greater than 2. I use 3 and 6 because they're perfect squares here. So if you plug in 3, that gives you 3 minus 2, which is 1. Square root of 1 is 1. So we get that point. And then 6 would give you square root of 4, which is 2. So 6, 2 is our other point. Square root function. Our domain is all x values greater than or equal to 2. And our range is all y values greater than or equal to 0. All right, it goes up forever from 0. It goes right forever from 2. (46) Square root inequality. So remember that x plus 2, that radicand gives us x equals -2. So our first x value is going to be at -2, and that -1 on the outside is going to drop us down 1. So our first point is going to be at -2, -1. Then from there, you can pick any x value greater than -2. I use -1 because it gives me a perfect square. Okay, use that -1 there. It's going to be square root of 1 minus 1. 1 minus 1 is 0. So I got that point at -1, 0. Then I use 2 because, again, it gave me a perfect square. 2 plus 2 is 4. Square root of 4 is 2. 2 minus 1 is 1. So I have that point there. Since it's less than, it's dashed line. And since it's less than, I shade below. 47, I need the same base. 8 becomes 2 cubed. And I need to distribute that to the x plus 2. Can drop the base. X minus 2 equals 3x plus 6. Subtract x, 2x, subtract 6, -8. X equals -4. 48, same thing. Need to get the same base. Bring up the 9. 3 to the 2x plus 3 equals 9 to the -1st. 9 becomes 3 squared, so that'll be 3 to the -2nd. Drop the base. 2x plus 3 equals -2. X equals -5/2 there. All right. Last 2 questions here. All right. All right, we need to write the exponential function. Y equals a times b to the x. We're looking for b, so we set that up as 625 equals 5 times b to the cubed, divided by 5. 125 equals b cubed. Cube root both sides. We get b equals 5, so our answer is y equals 5 times 5 to the x. 50, that'll be 16 equals 4 times b to the second, divided by 4. 4 equals b to the second. Square root both sides, b equals 2. So our answer is y equals 4 times 2 to the x.